This video is going to be a lab tutorial on the ccna exam topic NAT. There's also a routing protocol issue that I run into with OSPF that needs to be resolved if you're going to be trying to work on this specific lab and try to get it to work. So make sure to stick around to see how that gets resolved, and just much more to come. What's happening, everyone? You are now rocking with the best IT trainer in the game, Network Ninja. Today, the lab we're gonna go with is the OG of IT. If you don't know who that is, that's Keith Barker. Definitely go check out his channel and everything like that. I'm gonna be putting a link to his walkthrough video as well, just in case you can't get through this lab with my walkthrough video. The whole point of creating these videos is to just attempt to share my knowledge and hopefully help somebody out that might be stuck trying to study the ccna stuff. Before getting started and jumping into the lab, just gonna break down what NAT is really quick for anybody that doesn't know what NAT is, as well as PAT, because we're gonna be doing NAT and PAT in this video. So NAT just stands for Network Address Translation. And the goal of NAT is to take one network address, whatever IP address it is, and to translate that into another IP address. And then PAT would just be port address translation. In that, there are some limits to how you can configure it, depending on how you configure it. So PAT was designed to help out with those limitations. For example, IP addressing. There's only a certain amount of IPs that are available. So once you run out of that, then you can't translate anything more. So what PAT allows you to do is use one IP address and translate it to many different IP addresses by translating the port as well. So as you'll see in this lab, not only will the IP address, we'll be using the same IP address when we translate out to the public internet, we'll also be translating the ports when we do that as well. And that gives you more than tens of thousands of ports or connections that you can translate with, as opposed to having to have 10,000 IP addresses to translate with. Either way, to start off, let's get started with the lab objectives. So as you can see, the first lab objective is to leave the web DNS server with no default gateway. And how it was explained in Keith's walkthrough is basically, this is your web DNS server, and if it doesn't have a gateway, it doesn't have any other way of getting to any other network other than the one that it's directly connected to, which is 23.1.2.0. So essentially this can be, since it's the web and DNS server, essentially we're gonna say that this is the internet in perspective to this inside network of switches, a router here on the edge, and then PC1, which is the PC we're gonna be using today. All right, so lab objective number 2 is going to be implement NatxPat on the edge router so PC1 can open a web page, a server at thekeithbarker.com. So if we just click on here and we can look at services, DNS, thekeithbarker.com, there's an A record for the DNS record, which is just mapping this text to this IP address or this domain name, however you want to say it. But 23.1.2.2 is being mapped to thekeithbarker.com. Now the issue is that PC1 can't open that web pager of this server. So if we go to PC1, we go to desktop, make this bigger, as big as I can, and then we just type in thekeithbarker.com. Nothing's gonna happen as expected. Can't open the web page. We don't have much information other than the lab objective saying implement NatxPat. So let's jump into the lab and get started. All right, now that we are in the edge router, the way that you want to try to learn NAT, it's a couple of steps. So if you put everything into steps and create your own kind of process, that way that you can just, when you need to configure NAT, you can just do it off the top of your head. These steps usually help me out. So the first step is identifying the interest in traffic that you want to translate. In other words, what IP addresses need to be translated to a different IP address that's going to be represented to the public or the outside world. So to identify those, you can use an access list. And you don't just have to use ACLs to identify traffic when you're configuring NAT. Also, when you're configuring QoS or route maps, these are all times that you can use an ACL to identify the traffic that you want to apply that service to. So today it's NAT, like I said, so we'll just go into config mode, and our access list is going to be access-list 1 for a standard access list because we don't need an extended one. And then we're just going to put permit here because this is the traffic we want the router to identify, we want it to catch. And then it's going to ask us what is the address that it needs to match on, and then we're going to put 10, and it's going to ask for the wildcard mask, which is we just want it to match any network that begins with that first octet of 10, so we'll put 0 there, and then that's good. So now we're going to be able to match any kind of traffic that comes into this edge router that has an IP address that starts with 10. It will reference this access list as it gets processed to be routed. If you really didn't grasp anything as far as where I'm at now, as far as creating the access list and everything, drop it in the comments. Let me know what I could have said to make it clear. Also, if you don't understand wildcards and subnetting, drop it in the comments. Let me know if that's something that y'all want to do just a specific video on. All right, step 1, like I said, we just identified the traffic. But now step 2, we want to define the inside and outside of the network. So what I mean by that is everything where there's PC, everything up until this point right here to the edge router is going to be the inside of the network. Everything after that, like this web DNS server, that's on the outside of this edge router. So this interface gig 00 is on the outside, gig 01 is on the inside. So we said if we go on the interface gig 0/1, that is on the inside part of our network. So we tell NAT IP NAT inside. This is the inside part of your network. And then we go interface gig 0/0. Then we tell NAT IP NAT outside. This is the outside part of your network. Now that those are defined, we can get out of there and just go back into regular conf T mode or our config mode. And then now we're going to drop the NAT rule. So I guess this is what is called a NAT rule. Basically, this is telling NAT to translate these specific IP addresses and translate them to represent this IP address as well as PAT. And we're going to tell it to not only represent the IP address, but translate the port as well. So the syntax for that is going to go IP NAT inside. And again, just starting out, don't be afraid to just question mark your way through. It helps out, especially in the lab. This is where you're learning, because as you're question marking your way out, you're building the syntax, which is getting you used to all the options and understanding that, as well as what the correct syntax is really supposed to be. So IP NAT inside source list 1, that's the first part of this syntax, and it's saying we're telling NAT for the inside part of the network, we want you to look at access list 1. We want you to reference access list 1. Remember, up here, access list 1 was to permit any traffic with the first octet of 10 in it. So this NAT rule is going to reference that access list, and it's going to see any traffic when it comes through. It's going to process its IP address and see if it has a 10 in the first octet. Then we're going to put interface right here. And then what interface do you want to use? And ours is gig 00, which is the outside interface. So now this rest of this rule is saying anything that does have that 10, translate its address to the IP address of interface gig 00, which is our outside facing interface. And then lastly, you're saying overload. Overload means port address translation. So anytime you see overload, if you're on the CCNA, they're talking about port address translation. That is a key thing to understand. Overload just means that we can use so many more ports to translate with, because there's like 65,000 or so ports. I think it's 65,535, something like that, right? Of ports that we can use with the IP address of gig 00 to allow that many different kind of translations. So after we implement NAT, you'll see the translations and you'll see the meaning of overload and why port address translation is so important, hopefully. All right, that's pretty much it. So we've configured NAT so far. Now all we have to do is verify it. So to configure NAT, again, all you had to do was identify the traffic that you want to translate, then The next thing you had to do was tell the router which was the inside part of the network and which was the outside part of the network by putting that command on the respective interfaces. And then finally, you had to put in a NAT rule or tell the router what to do or what IP addresses to translate by telling it to reference the access list and to translate it to the IP address of your outside facing interface, as well as overloading it with port address translation. To verify, we're just going to jump in PC1 because that should be able to open the web page now. So if we go into PC1 and we go right here, Keith Barker, no dice again. So if we close out of there and we open our command prompt, we could just do some troubleshooting that's like ipconfig/all, see what kind of information we get. All right, so we know we're getting a valid IP address in the correct subnet. We also have a default gateway, and we also have a DNS server. So since we have a default gateway, let's see if we can ping our default gateway, 10.0.3. We can make it to our default gateway. So if we can make it to our default gateway, we should be able to make it to 23.1.2, which is a network outside of our network, but our default gateway should get us there. So let's see what happens. Ping 23.1.2.2, and we get a reply 10.0.11 says the destination host is unreachable. So now we just need to determine who is 10.10.0.11. So if we go here to our topology, I've already done this lab. So boom, 10.10.0.11 is this guy. So if we go into here and we go into Silly and we go into our troubleshooting, we're going to do a show IP route 23.1, and there's no network in that table for that. So if we look at the routing table, we see that there is not even any networks other than the ones that are directly connected for VLAN 10 and VLAN 20. These two networks, those are the only networks that this device knows how to get to. But if we look up here, we see that OSPF is running. So the next question would be, why wouldn't we see any OSPF routes in this table? Maybe because the OSPF neighbors aren't fully up. Maybe it says loading to full, load and done. It should have OSPF neighbors. So if we look at our neighbors, we do have our neighbors. So now the next step is to, let's look at why on our neighbors we can't get over to that 23.1 address. Now if we look, the only OSPF neighbor on here is going to be this guy that has a connection to that network. So we're going to go there and we're going to go to the CLI, and if we do show IP protocols, this will tell us what routes or networks we're advertising with OSPF right here, and it says we're only advertising the 10 network. So if we look on here, so if we look on the router, we have a 23 network and this 10 network. So we need for OSPF to also advertise this 23.1.2.1 network. And how we're going to do that is we can configure OSPF to just advertise a default route for any IP address. So once we do that, this router will now advertise to its OSPF neighbors that I know how to get to any network, just send anything over to me. So to do that, you go conf T and then config mode, and then go into the router OSPF1 process, right? And then the command to advertise a default route. So if you're connected to a network and you want to tell all your neighbors, I know how to get to any network, you just put in default information originate. And if we hit end, hopefully all that made sense. Now we should be advertising a different route. Let's go back over to this MLS1 device and do show IP route this time. Now we do see a static default route being advertised by OSPF right here, and it just came in 11 seconds ago and is being advertised. So now let's see if we can ping over there from this device, 23.1.2.2. Boom. We got success. We can make it over there. Now we go PC1. Let's run it back. And now we're getting replies. So the next thing, all we have to do now is, now that we're pinging it, let's jump in here, back into the web browser, and let's open the web page now, thekeithbarker.com. And boom, we made it to the site, and there's some links here we can click on, and if you wait a second, it'll hang, and then it'll give you the information from that web page. All right, I'm gonna add a final step if you're following along with this lab all the way till now. So this final step is really just verifying that. We already verified it by opening the web page, but let's look at how that looks like when you're verifying it through the command line here. You can use a couple commands, so you can use show IP NAT stat. And as you can see, this is going to give you some information as far as which one are the outside interfaces for NAT and which one are the inside interfaces NAT's using. Some hits, some misses, some expired translations, all of that there. Now, the main one that you're mostly going to use when you're troubleshooting NAT or verifying is show IP NAT translations. So show IP NAT trans, this is showing you the translation from your IP address, which is 10.10.0.10. That was the IP address of the PC. Let me show you right here. If we hover over it, 10.10.0.10. So now go back to the edge router, and it says 10.10.0.10 is making a connection to 23.122 on port number 53. Port number 53 is DNS, and then it's showing you outside global 23.122, and then it's showing you inside global 23.121. All right, let's look at all of these different terms. Inside global, inside local, outside global. Inside local, that's going to be the IP address before it's translated. Inside global, just think of this is the IP address. Global is I'm telling everybody this is my IP address. That's what everybody, that's the translated address. The local one is yours. Outside local, this is for the server side. So this is, it's outside local, which the IP address that it's really configured, and we're not doing any kind of translation on that. So the router showing there's no translation on this. And then outside global is the same IP address. This is the IP address that the public or the global sees the server being represented as. And then again, we have the port numbers being connected on for the server is 53, but our port numbers are 1027, 1027, 1029. We can use so many different port numbers because of port address translation. If we were to communicate without port address translation, we'd only be able to communicate on one port. So hopefully that makes sense, and that shows you the power of using port address translation, because you're going to get so many more translations than you would just using no port address translation. You would only be able to translate the IP address to an outside IP address, but your ports would never be able to be translated. So you couldn't have that as many translations with the same IP address. You would need another IP address if you wanted to use another port. All right, that wraps it up for this one. We configured NAT, and we also did a little troubleshooting with that routing protocol, and then we verified NAT. So that will get you through this OG of IT's lab. Hopefully you enjoyed this video. If you did, go ahead and click on the playlist that I got right here for you, as well as subscribe to the channel, because I got so many more videos like this doing labs in the playlist and more to come. I'll see y'all on that next video. Holla at me. Peace.